Today we are solving Leetcode question 745, Prefix and Suffix Search. Design a special dictionary that searches the word in it by prefix and suffix. Implement the word filter class. Word filter initializes the object with the word in the dictionary. Function f returns the index of the word in the dictionary, which has the prefix and then the suffix. If there is more than one valid index, return the largest of them. If there is no such word in the dictionary, return -1. Let's take a look at the example. We initialize the word filter with only one word, apple, and then we call the search function f to search by prefix a and the suffix e. So in this case, the index returned is 0. So now the question is how to solve it. So for the prefix search or suffix search, try is the first idea on top of our mind. But how to implement that? So by just simply looking at this example, one brute force solution is just to insert every possible combination of the prefix and the suffix into the trie for each word, and then record the corresponding index of the word. That would require a lot of storage to store every possible combination of the prefix and suffix for each word. Then the question is, can we do better? So now we can take a look at the hint. So the hint provides a very smart way to actually store the prefix and the suffix. So basically the idea is, let's say the word is apple. We'll insert into the trie apple, # apple, and then pple # apple. And then we can see that it's basically we are insert every possible suffix with the whole word. So basically that's every possible suffix plus a special character to do the separation plus the whole word. So why we are doing that? So in this way, you only need to consider every possible option for the suffix, and then it will be the whole word will be appended to the end of this string. So in that case, let's say for example, the suffix is apple, and then the prefix is just a. So in that case, this string will work. So for example, it will match the suffix apple and then the #, and then the prefix a. Let's say if prefix change to app, in this case, this string would also return a match. So this is equivalent to the starts with in the original trie implementation. I have a previous video talking about how to implement the trie. So in this case, instead of consider every possible combination of the prefix and the suffix, we just need to consider every possible suffix and then append the whole word to the ends of this string. And then this is what we are going to insert into the trie. Okay, when we do the search, so this search is equivalent to start with. So in this case, when we do the search, the input would just be the suffix plus this # plus the prefix. That's what we are going to search. So this is our trie structure. So how do we keep track of the index? So in that case, this index is determined by the order of the word in this initial word list. So in that case, so for the index, we can keep track of the index at each node. So basically, at each trie node, we also track the index. For example, let's say when we are insert this word apple # apple into the trie, we go from, let's say, apple. So we insert the first letter A, And then after we insert, we update with the index. So Apple, the corresponding index in the words filter initialization input words list is 0 because it's the first word. So in that case, so when we insert into the node A, so the corresponding index is 0. And then we continue down, insert P, and then P and LE, and then APPLE. So when we finish insert the whole words into the trie, basically for each node, we just update the index. And then later, let's say when we encounter another word, let's say we're insert something related to app instead of Apple, we just insert something related to app. In that case, the node, the common node, their index would just be updated. That's why it returns the largest of them. So the index will be updated as we are inserting more and more words into this trie. So this is basically the idea to solve this problem. So let's implement the trie. So first define the trie node. So remind that trie is just a tree data structure. So in that case, it has the children node. It could have multiple children. So that's why we are using a dictionary to track all the children. So in that case, self.children. And then we mentioned at each trie node, we want to track the index for the words inserted. So in that case, let's do an index. And then we initialize it to the value of -1 because that's the default return when there is no such word in the dictionary. So this is our trie node. So for the children, so this is dictionary. So the key is the letter or character. For example, it could be A in this case, and then the value is the corresponding trie node. And then next, let's code the trie. So for trie, let's initialize it. We want to initialize a root node. So this root is an empty string to track the start of the trie, or the top of the trie, or the root of the trie. And then let's implement insert. So we want to insert a single word into the trie. So every time we insert it, we need to keep track of the current node. So this is just a standard implementation of the trie with a little bit tweak to actually incorporate this index. But overall, the code is very similar to what we implemented for the trie data structure. So the current node points to the root node at the very beginning. And then we are trying to insert one character at a time from this word into the trie. So we check if this character has already been inserted before. So if it's not inserted before, then we add that. If it is inserted before, in that case, we just move on, traverse down this trie data structure, move on to the next node. After we do the updates, let's update the index. So current.index is the corresponding index. Okay, so in this case, for the insert, the input is not only the word, but also the corresponding index for this word. And then we are updating this index for each node. Why we are doing that instead of doing this at the end of outside this for loop? That is because let's say we are storing this the words in the trie this way. That's every possible surface plus the pound sign plus the whole word. So that which means okay for different options of the prefix, our insert, when we do the search. Let's say later when we do the search, our search could stop at any nodes instead of going to the end of the string. So in that case, we need to update the index at every possible node along the way, instead of just updating the index at the end of the string. So this happens within the for loop, because the way we are actually constructing our trie data structure to save some storage, because otherwise the brute force option would be just every possible suffix with every possible prefix. So here we just use every possible suffix plus the pound sign plus the word. So which means, okay, when we do the search and then when we are searching for the corresponding prefix, we could stop at any character here instead of going towards the end of this whole word. So that's our insert. And then let's code the search. So let's call it start with, because this is starts with, because this is a prefix search. So basically, given the search string, so given the word, given the search string, and then we start initialize the current node. So current node is initialized to the root node. So initially it points to the root node, and then we are still checking for every character in this word. If C not in current.children. So in that case, we just return -1. That means there is no match. So there is no such word in the dictionary. We return -1. Else, we just update current equals current.children. And then in the end, let's say we have find the match. In that case, we just return current.index. So this is our trie data structure. So basically, this is very similar to the original trie implementation, which I talked about in my previous videos. The only modification is right now in the trie node, we add the index to keep track of the index of the word in the input. And then when we initialize the trie, when we insert character by character into this trie, we update the corresponding index for the node. And then when we do the search, we actually do the search for starts with. Basically, we are trying to find a string in this trie that starts with the input word. That's because we don't have to go towards the end of the string stored in the trie, because when we are storing the string, we store every possible suffix plus the pound sign plus the word instead of the every possible prefix here. So this is the implementation of trie, and then let's implement the main function, word filter. So in the initialization, we are given words. So what we need to do is actually insert this into the trie. So we first initialize the trie. Self.trie equals trie. We initialize the trie, and then we start insert words into the trie. So basically, we need to construct the corresponding string for each word, and then insert them into the trie. So in that case, we can construct by, let's say, for I, basically for the index and word in enumerate words. And then we are trying to construct the string to actually insert into the trie. So in that case, the string is actually word plus pound sign plus word. So in that case, this is our input string. So the words we are going to insert into it. So let's call it input. Let's not call it input. So let's change to a different name. So okay, I'm really bad with names, so I just call it the W equals, and then for I in length word, we call self.trie.insert W I towards the end. And then also the corresponding index. So basically why we are doing this, so we first create an intermediate string by concatenate the whole words with the pound sign, and then also followed by the whole word. So in that case, I is looping through every possible character in this original word. So, and then we are trying to insert this the substring of this concatenate string W starting from the index I. So in that case, we first insert when I equals 0, we first insert the whole word, this apple, pound sign apple, and then when I equals 1, we insert the substring starting from the index 1. That's when we insert this PPLE pound sign apple. And then this F is our search. So basically for the search, the input into the trie is just self.trie.starts with, and then the input is the suffix plus the pound sign plus the prefix. So we just return this value. So this is our solution. Let's try run it. Oh, I made a very silly mistake. So this is actually the range. Okay. Key arrow A, if C not. Okay, so in insert, for the filter insert. Okay, line 23 in the insert. Oh, so in this case, if C not in current dot children, so I made a typo. So C, we check if this C is in current node's children. So because current node children is a dictionary, so we are checking, okay, if this character C is whether or not this character C in the children. Oh, another typo. Okay, so this solution is accepted. So let's go back and review this solution one more time. So basically for this one, we are actually constructing a trie data structure, and then we are trying to insert every possible suffix plus the pound sign plus the whole word into the trie. So in that case, we don't need to consider every possible suffix plus the prefix combination. This whole word appended to the end of the string actually saved us some storage so that we can store fewer strings in this trie. This is what we are going to insert into the trie. And then we are doing the search. The input to this search function is just the suffix plus pound sign plus the prefix that we are searching for. And then at each trie node, we need to track the index. So basically, that's why we initialize the self.index. And then during the insert, we are just insert this word and then the corresponding index into the trie node. And then we are doing the search, we actually it's start with. So basically, this is the word that or the string that we are going to search. And then we are just check, okay, if there is a match or not. If there is not a match, we return -1. If there is a match, we just update this current node to point to the next node, and then until we reach this end of the string that we are searching for. And then when we reach the end, we just return the index of the current node. So this is our trie data structure. For this word filter, the main function is we first initialize a trie, and then we are trying to insert this every word in this words list into the trie. So basically, we get an index and then the corresponding word. So this is the index we are going to insert into it. But for this word, we need to do a little bit tweak. So we first create a string called W. That's the word concatenate with pound sign and then followed by the word. And then we are trying to insert, what we are trying to insert into is every possible option of the suffix plus the prefix. So in that case, every time we insert, we are actually insert the substring of this W starting from position I. This I is in the range of this length of the word. So in that case, our insert into the string, into the trie is just, let's say we first insert I equals 0, we insert apple pound apple, and then when I equals 1, we insert PPLE pound sign apple. That's how we insert the whole string, the string, into the trie. And then after create this trie, we are just doing the search. So the search is just called start with, and then with this input string, that's a suffix plus pound sign plus prefix. So this is our solution for the prefix and suffix search. I would say this is not very easy to figure out. So I have to look at the hint to figure out, okay, this is actually a pretty smart way to insert into the trie.